students, coming to the last topic in the subject compiler designs was a peephole optimization. So what is this peephole optimization? This technique works locally on source code to transform it into optimized code. So the use of this technique is the source code what you are taken that locally it works on locally on source code to transform it into optimized code. The peephole optimization is a short sequence of target instructions that can be replaced by shorter or faster sequence instructions. Okay, so it's mainly concentrated on the shorter and the faster sequence instructions, okay, which gives the target instructions. It examines at most a few instructions, transforming instructions into other less expensive ones, such as turning multiplication of x by 2 into an addition of x with itself. The main aim of the peephole optimization means we want to reduce the instructions. Okay, without changing the effect of the expression, we have to reduce the instructions. So here this peephole optimization is replaced by a shorter or a faster sequence instructions. And also the less expensive ones, instead of taking the more expensive operators, it just takes a less expensive operator. Means if you take the multiplication like x by 2 means x into 2, that is a 2x. Instead of writing 2x, we are just writing x plus x. Because both are the same. 2x is equal to x plus x is a 2x. Both are the same. So instead of writing the multiplication operator, it's better to write the addition. Okay, wherever it is necessary. So that is the use of this peephole optimization is going to reduce, transform these type of instructions into these instructions. Okay, now let's see the different characters of the peephole optimization. The different characters are the redundant instruction elimination, unreachable code, flow of control optimization, algebraic simplification. So we had seen that peephole optimization is going to reduce the instructions and taking only the less expensive variables or the operators. So here the characters, whatever the character you are taking, every character is concentrating on that term only, because it redundant instruction elimination. Wherever the instruction is unwanted instruction is there, it is going to be removed. So that is one character. Unreachable code. If the code that is present in the source program, if that is not used anywhere in the program, you are trying to remove that code. That is unreachable code. And flow of control optimization. So the flow has to be controlled instead of jumping from one statement to other. Suppose if you want to reach to this top, instead of going like this, some points will go like this and come here like. Means flow of control optimization. So removing this type of flow and taking the less expensive flow, that is a flow of control optimization. And the algebraic simplification. So in the term of algebraic simplification also, we are reducing the sequence of the statements. Now let's see one by one the characteristics of peephole optimization. The first one is a redundant instruction elimination. So at source code level, the following can be done by the user. Let's take as programs. The source program can be reduced by the user in the following way. So here see. Here int addition 10, int x, I want to add 10. I have taken the integer x as a variable and integer y, z I declared. I taken three variables y, x, y, z, all are of integers. And I assign 10 to y. And I am making z is equal to x plus y. So here int I have taken something and that is I added to y, that is a 10, and return z. So this is a source program whatever I written. Now I want to eliminate this source program. Means I want to reduce it. A redundant instruction elimination. So wherever the redundant instructions are there, I want to be eliminated. So here I am just avoiding the z. Okay, this is a redundant elimination. Redundant instruction elimination. So the same addition 10 int x, I'm just taking the int y and I assign the y is equal to 10. I take in y is equal to x plus y. So whatever the result that is stored in x plus y, that result will be handled by the y. So here I am writing return y. Instead of return z, I just taken the y only. So only the two variables are sufficient. Again I reduce this instruction code. Int addition 10 int x. I have taken int directly initialization and the declaration I have written in only one step. I reduce the statements. Okay. If rather than performing y is equal to x plus y, directly I am returning x plus y. This is how I am reduce the steps, because everything, whatever the statements, whatever the program that you are taking, all the concept is the same. You will get the same result. But here I am reducing the number of instructions. I am eliminating the redundant instructions. Redundant instructions I am eliminating. And simply you can write int addition 10 int x, just return x plus y, because y you already initialized as a 10. So the y is a constant, that is a 10 is a constant. So instead of taking the y variable, directly you can return x plus 10. So for all these the output is the same. So at compilation level, the compiler search for the instruction redundant in a nature. So the multiple loadings and the storing of instructions may carry the same meaning. So these are all carrying the same meaning. So here all the multiple loadings and the storing instructions may carry the same meaning, and even if some of there are same meaning, so just remove those items. Okay. So now let's see the next characteristics in the peephole optimization, that is an unreachable code. Means if the statement that you are not using at all in the program, if it is no use of using that statement, just remove that statement. It is a part of the program code that is never accessed because of the program constructs. A programmer may have accidentally written a piece of a code that can never be reached. In some situations, the programmers may accidentally written the statements by default. Means it's a habituated, they will write the statements. So that statements can be removed. Like here void addition 10 int x, I am just taking return x plus 10. And I am writing the printf statement, because whenever I perform some operation, the result, if you want to show it on the screen, I used to write the printf. Okay. But here writing the printf is waste, because you are already returning the result. Return x plus 10 means in this statement, the printf will never be executed as program control returns back before it executed. Because here it's already returning the statement. It is returning on the screen, means the result will be displayed on the screen. So the printf statement will never be executed, because the program controllers return back before it executed. So hence printf can be removed, because it is an unreachable code. Now let's take the next characteristics of the peephole optimization, that is a flow of control optimization. These are instances in a code where the program control jumps back and forth without performing any significant task. These jumps can be removed. Flow of control optimizing means reducing. The flow of control can be reduced. Okay, in some situations there is no use, you are simply jumping from there to there. Okay, and again you are coming back to the same step. Okay, in that cases, just remove the unwanted jumps. See here in the program, move R1 comma R2, go to L1. So whenever I go to L means the controller jumps to L1. So here again it has without performing any operation, it is L1 is saying go to L2. Go to L2. Here it is not performing any operation, simply it is saying go to L2, and here increment R1 operation is performing. In this code, L1 can be removed. Why L1 can be removed? Because it passes the control to L2. Okay, so instead of jumping to L1 and then to L2, the control directly reaches L2, it's better. So here just I removed the unwanted jumps. I removed this L1, go to L2. In place of L1, I placed L2, and the controller directly jumps to the L2. Okay, because this is an unwanted jump. Here we are performing no operation. So if no operations are performed, then just remove that jump. And coming to the last characteristics in the peephole optimization, that is algebraic simplification. These are the occasions where algebraic expressions can be made simple. So it's, see here, a is equal to a plus 0. Is it necessary to use plus 0? Because a is equal to a. So a can be replaced by a itself. So then why we are writing this statement? So this can be removed. A is equal to a plus 1. So instead of writing a is equal to a plus 1, it's better to write increment a. Increment a is nothing but a is equal to a plus 1. Okay, instead of writing this algebraic expression, it's better write a statement increment a. That means a is equal to a plus 1 only. So these are the different characteristics of the peephole optimization. I hope you understand this subject. If you have any doubts regarding this subject, please comment us. Thank you.